Now that we're talking about PAT, I wanted to get your perspective on something, Sven. And I have my own opinion on this, but I'm sure people are more interested to know what you think. Um, when it comes to PAT, it's quite interesting to me that everyone who is running a bioreactor is measuring pH, dissolved oxygen, and temperature. And these are done online, or inline, if you will. Everyone is also measuring their cells in some way, but most people are still doing this offline. And Trypan Blue, I guess, is probably the most, standard gold, can be considered as the gold standard in our industry, even today. I've always wondered why there hasn't been a more active adoption of not just capacitance, but other inline technologies that are out there that are equally promising.
That's a very good question. If I had the answer, Aditya. So what we know is that it took us, and it still takes us, much longer than we thought when this PAT initiative came out in 2004, right? So yeah. As an industry, we're not exactly fast. Now, I have a bit of a background. We're not as slow as in the vaccine industry, where nothing will ever change. But we're still, cell culture is not, it's not an industry which turns around quickly. So it takes, more than a decade to introduce technologies which are not, that, in my mind, not that risky to implement. But there are reasons for that. And one of the reasons you indirectly mentioned it early on when you said that when you're in a process development setting and you're moving from, for example, shake flasks and experiments where you have 20, 50, I don't know how many shake flasks which you run in parallel, and the only thing you have is Trypan Blue counts, and then you move into bioreactors, and all of a sudden you add capacitance to it, and you have, a fed batch process and a type of feeding regimen that you have developed, which is based on Trypan Blue counts. How do you translate that into something which all of a sudden works on capacitance? So this is one of the challenges. The other challenge is that we did not know, and I think we know enough now, what the signal means. For a certain time, for a couple of years, we didn't know enough about what's in there and what's hidden in a signal. And this is something that people in later stages, in particular when you go into GMP, you do not want to have signals that you don't understand, right? And on which you have to take then actions. You don't want to have a deviation coming from a signal which maybe is not, you think, helpful, and where you're just monitoring. You don't want to have a probe fail either. So again, coming back to Biogen, I think they help there as well, because there's a paper on how can we validate these probes when they come in. What do we use as a kind of live viable standard to test that my probe is still working. Now, I think we're at a tipping point though when it comes to implementation of PATs and PAT technologies. There's capacitance, which for me personally, this is a must do. The limitation that I see though is that we do not have the ability yet to, and this is something I hope you can speak to more, to measure capacitance early on in process development.
Yes.
So we measure quite, and I see though that recently a company, without naming it, they launched a Raman tool, right, for high throughput process development.
Yes.
So this is, I think we're going into a direction where we will use technologies such as capacitance. And since I'm there, I wanted to add that although this is a very helpful tool, I don't believe that capacitance can be standalone. I think it should be, and it will be potentially somewhere at some point in the future, combined with other complementary tools, which ideally provide us information, because what capacitance will not do, bioreactors is a bit different. It will hopefully tell you when viruses come out of the cells.
Yes.
But it will not tell you what's the concentration of your product. So if you're able to combine something such as capacitance, which looks at the cells,
Mm.
the biomass levels, and then you can use that for control and to your control feeding, etc. In an ideal world, in 2030, let's have that call again. And then you combine that with a complementary technology that's looking at, let me call it the molecular level, or it could be the protein level, and it could be Raman, it could be something else. We're doing some studies on
Yeah.
fluorometry.
Yeah.
And then the challenge for you will be, how can you integrate that ideally into a single probe, right? Or into something that is compatible with most of the culture vessels that are used right now. Because the earlier you get it into your process, the more valuable it will be, and the stronger will, or the easier it will be actually to convince people to take it all the way through into GMP manufacturing.
Yeah, I think that is a very relevant point, Sven, and I can certainly talk a little bit about it. So, yes, I think for any technology, first of all, let's talk about the fact that capacitance is a relatively new technology compared to Trypan-Blue measurement of pH or dissolved oxygen, right? Even though it's been around for more than 30 years now. But for any relatively new technology, you've got to go through that transition of being used in the lab, understanding what the technology is actually measuring, as you said, and then once you've got the confidence in that technology, then transferring it to manufacturing, and that is quite a big transition for a technology. And we kind of um, went through that transition about 15 years ago, I would think, around about that time, where the industry really warmed up to using capacitance in manufacturing. And it's not just about the technology being understood really well, but also about the offering, how reliable the system actually is, how robust is the system. Does it come with validation packages? Does it come with system check procedures? Because obviously manufacturing environment, as it should be, is quite risk averse. So you need to devise strategies to see, you've got to sort of think about the worst case scenario and then see whether you've got a plan for that. So it is not an overnight success when it comes to technology being used in manufacturing. So that certainly happened, and we are still obviously,
This is, Aditya, one way of saying that you as a supplier also, you had to in a certain way adapt to this, right? And you had to
absolutely.
listen to your customers and their needs.
Most certainly, yes. I mean, we've learned so much along the way from our customers and industry experts. Excuse me, because using the technology in a lab and using it in a manufacturing space is a completely, a different ballgame. That's point number one. Point number two is, you mentioned that the technology should uh, be applicable in multiple scales. And I think that is a very relevant point. The way our industry is evolving, bioreactors are getting smaller. High throughput screening, excuse me, is a very useful thing to do. So it is really crucial for a technology like capacitance to also be available in smaller volumes. Um, a couple of years ago, we did launch a probe called the Futura Pico, which is by far the smallest diameter probe on the market. It's a 7.5 millimeter diameter probe, and that was initially designed for the smaller bioreactors like the Applicon minis, for instance. But we now have empirical evidence that it also works in much smaller platforms like shake flasks and even in centrifuge tubes in some cases. So but I don't think that this is the end goal, though. This is not the end objective. The Futura Pico was only meant to be a transition to going even smaller. Now, when that's going to happen, I'm not sure.
Actually, my one of the questions that I have for you is, how small you think you can go with these probes?
Well, my engineering team is going to. I'm not going to be popular with my engineering team if I make very bold claims on the during this conversation. The biggest challenge, I'll tell you, of going smaller with capacitance sensors is, of course, as you know, we work with 4 electrodes that produce the infinitively small electric field that performs the measurement. These 4 electrodes, the space between these 4 electrodes is quite crucial in terms of how reliable the measurement is. So the closer together these 4 electrodes are, the more problematic, if you will, the measurement. So as technology develops, um, there is a potential of going smaller. So if you notice on our conventional larger probes, the electrodes are further away from each other. But on the Futura Pico, they're much closer together, and we've solved the problem of the challenges of keeping the electrodes smaller. How small you can go, I'm not sure. But
Mm.
our effort will always be to go as small as possible,
Interesting.
realistically.
So let's not put more pressure on the engineering team than they
Right.
already have on their shoulders. But basically, what you're saying then is that the you were mentioning a scale of bioreactor. I'm not familiar with the brand in too much detail. I mean, Applicon, I know them well, but the Applicon Mini, that's 1 liter, or is that smaller than?
It's smaller than 500 milliliters. Yeah.
Okay, interesting. So we're
Yeah.
already smaller than 500
Yeah.
milliliters.
Yeah.
And then, so there's still a range to cover from, let's say, a shake flask is 20 ml, and for some reason, I'm thinking about 15 ml. So covering 15 to 250 ml should not be too difficult then.
Yeah. So you mentioned high throughput screening earlier as well, right? And certainly the effort would be to uh, to to to, to make our technology accessible on these platforms. But that's certainly where things are going, I would think. So, but I'm glad that you sort of very adequately summarize the challenges of adopting a technology like capacitance in the industry. And I think having identified those challenges, I'm also pleased that we're working on those to make them, a thing of the past, if you will. So that's great, Sven. I think we've covered the implementation, the evolution of the technology as such. If you wouldn't mind, we can talk a little more specifically about your work with capacitance measurements. And of course, you have so many excellent publications over the years, and I know for a fact that a lot of the scientists in the industry and academia have benefited from referring to your papers. So, if you wouldn't mind summarizing the work that you have done, and I know you mentioned earlier a little bit about viral vectors, etc., but I'm sure everyone would love to hear a little more about that.